Welcome back to Architecting Intelligence. Last week, we drew a hard line on when to completely skip LLMs altogether. But let's say the business case is clear, the use case is defined, and you absolutely know you need AI. Well, now you face a completely different, multi-million-dollar crossroads. Today, I'm taking you through a high-impact explainer to map out the definitive strategic framework you need to navigate this, protect your IP, and fiercely guard your engineering budget. So here is the defining question. Do you build it, buy it, or fine-tune it? It looks deceptively simple, right? But once you know you need that new capability, you have to strategically decide exactly how to source it. And honestly, most teams get this entirely wrong. They don't get it wrong because the options are technically complex. They get it wrong because they optimize for the decision they're most comfortable with, rather than the one that actually fits their architectural reality. I actually wrote about this in a recent Substack breakdown, noting that the wrong choice creates obligations that compound for years. This isn't just a quick technical pivot. This is a high-stakes, long-term commitment. Think about it. A bought system that you literally can't customize. A built system that eats up way more engineering capacity than it's worth. Or a fine-tuned model that turns into a massive, unmaintainable liability 6 months after the engineer who trained it leaves. These are the exact mistakes that will haunt your tech stack for years. Okay, let's dive into this. We're going to use a clear, consultative framework today. First, the strategic trilemma. Second, breaking down sourcing lanes. Third, the strategic triage matrix. And finally, total cost of ownership and vendor traps.
All right, starting with Section 1, the strategic trilemma. This is the ultimate balancing act between control, speed, and cost. Listen, you absolutely cannot have all three. If you shift completely toward buy, you get incredible speed out of the gate and super low initial costs. It accelerates you rapidly, but you completely sacrifice control, and that can absolutely crash your long-term margins. On the flip side, a pure build gives you maximum absolute control, but your speed totally plummets, and you just bleed engineering hours and money. And then there's fine-tune. It sits right in the middle, giving you medium control and speed, but it introduces an incredibly high ongoing maintenance burden. You have to know upfront what you're willing to sacrifice.
Let's move on to Section 2, breaking down sourcing lanes.
You know, organizational culture usually dictates how a team fails here. Teams under immense delivery pressure, they almost always fall into the buy trap. They want that short-term velocity. The instinct is, hey, the vendor already solved the hard problems, right? But they completely underestimate the customization limits and end up with severe vendor lock-in. Contrast that with your engineering-heavy teams. They fall right into the custom build lane. They want IP ownership, and they optimize for engineering pride because they think ownership automatically equals control. But they vastly underestimate the time to value and the massive opportunity cost of blowing engineering cycles on base infrastructure instead of actual product features.
And then we have the third lane, the fine-tuning wedge. This is often achieved through open weights leverage. Basically, this means deploying a localized model on your own specialized enterprise data to strip away those third-party API dependencies and scale your unit economics. Now, teams with heavy ML expertise love leaning in here. The instinct is that domain specificity is the ultimate path to quality. And honestly, it's often chosen just because it feels sophisticated. It produces killer demos. It signals ML maturity. But I'm telling you, it is perhaps the most seductive trap of all.
Because it brings us to a very harsh reality check. I want you to answer this honestly for your own organization. If the two people who understand this model's training pipeline leave next quarter, what is your plan? Seriously, think about it. If your answer is, we wouldn't be able to retrain or modify this model, then your fine-tuning decision didn't actually create a technical solution. It created a massive, hidden personnel dependency. You literally just traded a vendor contract for the hope that two specific individuals stay motivated and never get poached.
Now let's look at Section 3, the strategic triage matrix. Now, what's really interesting here is this actionable blueprint. It is an exact, ruthless, 4-stage tactical flow tree. You have to be disciplined and answer each one honestly before moving to the next. Step 1, compliance posture. This comes before any technical evaluation. If you're in healthcare or finance and your data has to stay within a defined perimeter, external APIs are instantly off the table. Step 2 is the differentiation test. Step 3, maintenance capacity. Literally name the person or team who will own this in 2 years and assess if they actually have the skills. Step 4, total cost of ownership. We don't just model development costs, we model the long-term reality. Do not skip these uncomfortable questions.
Let's actually zoom in on Step 2 for a second, because this is where you really need to audit your core differentiation. You have to ask yourself, will your competitive advantage come from doing something entirely unique,
or from just doing something standard, reliably. If it's a unique competitive advantage that requires deep knowledge of your proprietary data, great, building or fine-tuning makes total sense. But if it's reliable table stakes, something your competitors also have and your customers just expect as a baseline, like basic HR text summaries, just buy it. Reserve your expensive engineering investments exclusively for your unique advantages.
Which brings us to Section 4, TCO and vendor traps.
The crucial point to remember when buying an AI capability is that you aren't just paying a monthly fee, you are making massive implicit bets. Calculating your true total cost of ownership means modeling the hidden scaling costs just beneath the surface. Are you modeling inference at your projected scale? What about the painful cost of API migrations when your vendor decides to deprecate a version? What if the vendor updates their model's behavior and suddenly it degrades performance on your specific use case? You have to design a contingency in advance, explicitly document the assumptions you're making, and have a rock-solid plan for when those dependencies become unstable. When you project this out over 3 years, notice how the buy lane starts off looking fantastic. It's cheap and it's fast in year 1. But by year 3, as your usage scales and vendor pricing models evolve, the cost becomes absolutely catastrophic. Meanwhile, the build or fine-tune options definitely hurt in year 1. They demand high capital and high effort, but by year 3, your unit economics become highly predictable. A system that is cheap to buy today is very often not cheaper than a predictable, slightly more expensive custom build when you scale it out over 36 months. Technical choices can be reversed, but strategic commitments compound in both directions. So don't let vendor hype dictate your software sourcing strategy. Audit your core differentiation, choose your lane wisely, and execute with absolute clarity. Next week, we'll expand our architecture blueprint into our next core topic. Hit subscribe to continue building systems that scale, and be sure to read the complete strategic breakdown on my Substack. But before we wrap up today, I want to leave you with one final provocative thought to take back to your teams. How many fine-tuned models running in your organization right now could actually be retrained if the original engineers vanish tomorrow? Think about that. See you next time.